Hello, welcome everybody. Thanks, Stephen, for inviting me for the community call. It is actually the first time, and he asked you a couple of times before. So again, I'm a colleague of Stephen. I want to shout out to Stephen for organizing all this work around the communities and enable everybody to be able to speak. That's much appreciated. Normally we are sitting actually next to each other in the office, but we haven't seen each other for some time, and I guess that's the same for most of you folks. So online it is. Today I want to talk about the DID, or Decentralized Identities. This is not a topic which hasn't been discussed before. We presented around this at Ignite, at Build. See, this is my interpretation of the technology and the platform. I'm a developer guy, so I typically work with developers, help them integrate their solutions with our identity stack, like AD or BTC, although more AD to be honest, using our libraries, explain how they work. I've been assigned to work now with the decentralized identity team and help them do the first proof of concept and pilots with our customers and train our partners. So I like to talk to what is decentralized identities and why we think it's important, and also why you should or should not care as a developer or an architect. I want to explain a bit how the technology works, and there's plenty of time for Q&A. Feel free to ask the questions. I am as well. You can speak up if you're not shy as well. More than happy to get you any answers, and maybe some other folks can chime in as well if they want to. So yeah, let's just get started. So before we start diving into what decentralized identities are, I was like, well, what kind of solutions are at this moment hard to build? So I've been doing some architecture on identity systems, and I'm not sure how experienced you folks on the phone are, but if I think about building any of these solutions here, I think, yeah, this is not impossible, but it's extremely hard. So if you want to allow access to an expense tool, if people did some kind of compliance training, well, what would you do in the expense tool? When people log in, you probably will do an API call to the training system to figure out, did Stephen actually finish this training this year? Did Matthijs do that when he logs in? If that's true, okay, I'm gonna grant you access. That's not impossible to do, probably not even that hard if there's an API of that coming from the training system. But now I want to accept certain trainings from LinkedIn or Microsoft Learn or Pluralsight or something else. It's getting more complicated because if they have an API, they're probably all different. How do you authenticate against those and get that information out there? So these systems can be hard. Or in the case of 12,000 companies want to work together, this is, for example, NHS in the UK, setting up for one company federation with 12,000 different companies and do that for all those 12,000 companies so their users can actually start collaborating together. I'm sure if you're a consultancy company, you would love to set it up for the companies because it's a ton of work, but you can see that this is really, really hard. Or allowing a 50% discount for any student in the country. How do you check if somebody is a real student? Check an age, so you know that people are older than 20 or 21 years old. I know with AD B2C, we actually have a check for people if they are a minor or not. So the 21 years can be flexible, but just proving that you are 20 years old or older to be able to buy alcohol in the store, for example, that's something which is hard to do today. The last one, and this is actually a real case for companies, like, well, I want you to prove that you actually have a degree in medicine. You are allowed to practice medicine, so you're not like Dr. Phil. You can call yourself a doctor, but you can't practice medicine. And you work for any of these companies, then I'm allowing you in. So these kind of scenarios are hard to build today with the current technology where we have central IDPs, and this should be easier to build with the decentralized identity technology. So this is more my introduction. Okay, well, what kind of solutions do I think about when I'm a developer or an architect, and how would I solve these? So that in mind, like, okay, well, you're now thinking about, oh, well, I would build this system, I will build this system. Let's see how you would solve this. we are building this, and the current state is typically your identity consists of a username and password, hopefully with MFA, although we are moving to a more passwordless environment, but your identity is typically tied to a app with a username. All right, but it's more. Identity is everything you do, right? You get your achievements, you buy stuff, you play your games, it's at work, it's at home, your education. Although we think, well, it's all unique, we typically reuse usernames and passwords everywhere with all the problems coming with that, right? If you're doing anything with identity, this should be known. Endless breaches of personal data. We spend billions of dollars to do audits and actually prove things. There's a lot of people who don't even have a valid identity like a passport or a driver's license. And in some cases, entire identity systems disappear, including your identity. So what our customers ask is, well, I want more privacy and control over my identity and my data. And the question we typically ask is, well, do you remember the last 20 websites you've used, what account you used, and what information you shared with those websites? I don't know. And by the way, you probably share a lot of stuff meanwhile because you still signed into Facebook on all those different sites as well. You want to be protected from hacks and breaches, right? And organizations, they have a lot of requirements as well. They want to collaborate with a lot of people. It's not just internal anymore. Reduce risk. GDPR is a big thing, especially in Europe. The anti-money laundering systems, the financial organizations have to get in place. Governments, they realize IDs are not just for inside of the country. You want to cross borders, and agencies, refugees, they need an ID as well. So there's a lot of discussion, demands, and requests around identities. What we want to do is make sure that the user is in control. So we get back all the identities back to the user. They decide when and what to share with what organization. So there's more the high-level statement, right? We want everybody to have a digital identity you own and you control. It's secure, and it can store elements of your identity securely, and you control when you want to expose what information to whom. But it has to be seamless integrate, right? We can make technology which is not user-friendly. At that time, the technology will fall apart, even if the technology is really, really good. So the user experience is actually key in building these kind of solutions. All right, how does this look like in practice? So let me just show you something and let's see if it works today. I got my phone here, an Android phone, and I have my projection here. I got my website here. So let's minimize this one. All right. So I'm a student. I can log into my student dashboard and I log in. I can now get a digital version of my student card. I start Authenticator. I scan the QR code. It wants me to prove that it actually is me. I logged in already, that's why it's so quick. I accept. And if everything works correctly, I'm now issued we call it a verifiable credential, a digital identity on my Authenticator app or my wallet. So I have my university card here. There's some details, where did I use it. Everything is stored on my wallet. We call it the Microsoft. This is Microsoft Authenticator. It's the wallet. So now I got my digital identity for my university. For example, the scenario I told you, I want to give discount to any student. So this is a website where they give discounts to those university students. So it asked me to, well, can you prove that you actually are a student? So what I can do now, scan this QR code. I can choose if I want to share my information with the Fabricam bookstore. If I click accept, the bookstore says, oh yeah, that checks out. It really is somebody from the Contos University, and I now should have some discount on the books. So this is how the user experience looks like. So I got myself one or more identities. I got a business card, I got a verified employee card. If I now look on the activity, I can see it was verified when it was issued by the Contoso University, and then now it's verified by the Verifiable bookstore. So I actually have a receipt of every time I'm using my credential. And I should be able here to revoke access to the bookstore as well when I decide to do that. All right. So how does all this magic work? Because this didn't seem very complex at all, and I think that's a good thing because every user experience should be easy. And there's still a lot of work we have to do, and I'll talk about those details later. So I didn't do a build-up slide. So all these different pieces we have in place. In the middle is the user agent, the wallet or the authenticator app in our case. And in the text beneath is that we try to build everything standards-based. We are working in the DIF, the Distributed Identity Foundation, and obviously the W3C to make sure that everything we do is based on a standard. So I got my wallet, and the specifications are still in working order. I can store some information about myself. In this case, it's done in the wallet, but this could be something in the cloud in the future as well. I can exchange credentials between myself and a resource like the website, and I'll talk about how that works in a little bit. That's all based on the Verifiable credential standard from the W3C. And the big difference here is, well, we talked about decentralized systems, is if you are familiar with how AAD works, and let me just go to the next slide to talk a little bit about the details. So Contoso University is going to issue a credential to me as a user, and I'm going to use this credential at an employee or a bookstore. I think this one is clearer. So what happens is, if you're familiar with current technology like AD or B2C or identity server, whatever IDP you use, what happens is you go to a website, the website says, I don't know, go away, I don't know who you are. They send you back to that central IDP they register their application with. That's always a single one, sometimes two, but typically a single one. There you sign in, AD shows you a nice login page, username, password, MFA, FIDO, whatever. You get back an ID token. That's what you present to the website. The website sees, well, here's an ID token. Well, Matthijs, there's a key ID in the header and there's a signature on the bottom. Let me check that signature. It goes back to the hard-coded endpoint from the IDP, retrieves the public keys, validates your ID token to make sure it's signed with the private key of the IDP. If that checks out, it knows it's me, and it signs you into the website. What we're now creating is, since I have my own identities issued by any or more issuers, how do we validate if that's actually real? So what happens is that Contoso University publishes their public key material. Me as a user, when I got my identity, my public key information is published in a central in a distributed database as well. The same with the websites. So when I present my verifiable credential to the site here on the right, there's two signatures, one from the issuer and one from me. So how does the website check if the signatures are correct? So what they do, they go to this distributed system here, and this is based on blockchain technology, and retrieve the public key from me. So it knows, like, well, wait a minute, DID user, what's your public key? DID issuer, what's your public key? And then it can actually verify if those signatures are from those people. That's the biggest piece of differences versus a central identity provider. So instead of going back to a central place to retrieve public keys and make sure it's actually coming from that central place, we can now get public keys from a distributed database. And in our case, we're using the Bitcoin blockchain to make sure you can actually validate credentials. So if I am an employer and I want to be able to validate diplomas from a user, I can go to, there's not a click through. I can actually go to check diplomas from all the universities in the US. So it doesn't have to be a single university, and all those universities can actually issue those diploma credentials by themselves. So what isn't VC for real? It's just a JOT. So you can see one. If you're familiar with ID tokens, they look familiar. There's a header, obviously. The key ID is here. Typically that's like a number, and you go back to that IDP. Well, there's no central IDP because I'm my own IDP. So you go to the decentralized database, retrieve that public key, and validate the signature, which is on the bottom. That's simply, really simply simplified what decentralized identities, how that technically works. Microsoft is building a few pieces of technology, and I'll go to the list later. But first of all, you have to be able to issue credentials. So we're building a credential service on top of Azure Active Directory, which is now in private preview, where you can actually create and design those credentials. Think about an electronic diploma, or you're proving that you're working for your employer, passport, driver's license. Anything can actually be a credential. Questions. So Richard was asking, enable federation for multi-tenant. If you're in the case of AED, everybody in AED, that's correct. But from those 12,000 companies, for example, assume that most of them they don't have AED. Some have Ping, Okta, or another IDP. So if it's going to be outside of AED, then the federation is going to be complicated. If you want to limit the tenants you're going to trust, and I guess back to this scenario, what if you want to trust just Contoso, and we're going to talk about how that verification works, is actually a interesting problem we still have to tackle. How do I know this is actually Contoso University? How do I know it's not just Matthijs spun up a Contoso University issuer, because anybody can be issuing identities and say, well, I'm a university. So what typically works is like the employer has like a list of universities, or they have an address where there's a company who maintains that list of real universities, and they have to capture the IDs of those universities. Same happens how do I know if I have a license to practice as a doctor? Well, in the UK, there's an organization who actually tracks that information. So they should provide a list with trusted issuers of companies who prove that you can that you have the license to practice. So this always comes down to, where does the trust start? If you compare to public key chains, there's a root CA. Okay, which root CA do you trust and which one not? So that kind of system you have to think of. So we're building the infrastructure, but the trust system is still something which has to happen. So universities have to come together and make sure there is like some kind of database with real universities I can get to, and to make sure that when I start validating those credentials, I know it's coming from a valid university. So Kevin, I'm not sending 2 ID tokens. I'm sending 1 credential with 2 signatures. So one is from the issuer who gave me the credential, and one is from me. So it's the employer knows it's actually coming from me and not somebody else. So Paul, yeah, I hope that answers your question. So I'll talk a little bit about the code, how you can specify what issuers you want you're requesting, because that's something you want to do for the user anyway. So the few things you have to do is you have to design the contract, so what's in the credential, and also how it looks and feels. So you can understand, when we're going to work with customers, we're going to spend most of the time about the color, the icons, and the images, and the rest is spent on implementation. It's like a SharePoint project. We spend most of the time on the look and feel, and the rest is done on implementation. It's not going to be different here. So here's the card design, title, there's an issue, some colors, etc., etc. It's not really dynamic at the moment, but this is just a first version. There's some claims I want to collect, a student number and an expiration date, and maybe a profile picture, nothing fancy here. Then there's how do I get those credentials inside of this VC? There's different ways today. I can self-attest. So you ask the user, what's your favorite color? I can map from a ID token. That's what we did here. So I map the claim student ID, given name, family name to the claims inside of my VC. So whatever the ID tokens provide, you can map. I can also ask for another credential to be part of it. So for example, I will only issue you student card if you first present me a, I don't know, citizen card or a passport or a driver's license. And I can use the claims from that credential to create a new credential based on that VC and perhaps an ID token as well. So you can combine those different systems to create new credentials. That's where the case is. I want to prove identity by providing a passport or driver's license before I'm going to hand out this other credential. So what happens in this case, I was logging into the website, but you can imagine sending an email to a student. Here's how you can retrieve your digital identity. They scan with their wallet. And what we do, show the card. They have to sign in. This is the request we actually send to the Authenticator app. And we're going to ask you to, well, this is the credential type we're going to create. That's the student ID credential. That's just a string. And the contract can be downloaded here. That's something we create after you upload that display file and that claims mapping file. And then Authenticator knows what to do and how to sign you in. So the contract is actually what decides where you're going to get what claims from. Of course, the request is signed by the issuer, so the Authenticator can actually check if the request is coming from the right party and it's signed correctly. The student logs in, signs in, so you get an ID token back. It's a regular OIDC, you can see it on the top. Nothing fancy there. There's a payload you get back, and that's something like the first name, last name, the student ID. We can then map back to the credential, and they can accept the card. The card is actually signed by the issuing service. We ask you for the fingerprint to store the private key. And then we issue you the credential, like I said before. So there's the issuer, the identity, there's the subject, and there's the signature from the issuer. Oh, I couldn't have click through. Sorry about that. I got my credential, I got my claims, student ID, etc. We also have a link where somebody can check if the status of the credential is still valid. So once I present that credential, there needs to be a way for the relying party or the website to validate if that credential is actually still valid, because I can carry it along on my phone, but maybe somebody revoked it because of reasons. So we provide a way to contact a issuer to see if that status is still valid. This also brings an issue to light as well. Wait a minute, how about privacy? I don't want to know that bookstore calling my issuing website, which is university, so they know I'm trying to buy a book. So that's actually a real problem we still need to figure out how to solve. For example, thinking about, but it has to be a standard way, so everybody working in this area can do it the same way. Maybe we should store revocations in a distributed database on the Bitcoin, the blockchain ledger as well. So we can look up status of those credentials in a decentralized way instead of going back to the same issuer. But today's status is that we're going to do a callback to the issuer to figure out if that credential is still valid. And obviously, there's the signature of the DID, the issuing DID, so we can validate if the credential is correct. And then it's stored in my phone. What happens if I want to verify my credential? The bookstore actually sends the right request, so Authenticator can come up with the right cards. So the relying party or the website says, well, I need a student card from Contoso, I need a driver's license, I need a passport, or maybe I need 3 of those before I can actually sign you in. That's up to the relying party, and then Authenticator can actually figure out, wait a minute, I got these cards or these credentials on the phone, all these are relevant, and the user can actually pick and choose if that's relevant, which one they want to use to prove that they are who they say they are. For example, a relying party can ask, well, I want you to prove your identity, but either your driver's license or your passport. and a user can then choose which one they want to use if they have both. And how we do that is by creating those attestations. So there's the one here in the middle. And in this case, we only want to provide, I want a credential type of student ID credential from a Contos University, and that's the only one I trust. I can actually add, well, and only from this issuer. So for example, I want a driver's license issued by the DMV and a passport licensed by, is that the, I don't know, whatever department it is in the US. I don't have a US passport. So that's the combination you can do as well. This is our own presentation language, we call it at the moment. And we are working with the DIF community to come up with a more flexible language, and I can share the link later. It's still a standard in progress, and you see that in this world a lot where we try to figure out standards. Of course, the signature from the verifier is there, so you can check if you are actually going to present information to the right website. The student unlocks the card with a fingerprint and responds with the credentials. This is the one I just showed before. With the signatures, the subject needs to match with me, so they can find my identity as well. And then the bookstore says, oh yeah, it's actually the student, and give you the discount. So going back to presenting that card is, at this moment in time, we ask you, give me your credentials. And I don't know if people remember, but the credential, the case was my diploma. I got an engineering degree, the date when I graduated, and my GPA. I don't want to share all that information to the bookstore. I only prove that I'm a student. Or maybe I only want to, which degree I have. So what we need is a system where we can selectively disclose information for my credential. But as you remember, that credential completely was signed by the issuer. So if I start taking it apart and just provide pieces of that credential to the bookstore, the signature will be wrong. So we're now thinking about there's a few technologies they can use. Zero knowledge proof is where you can actually provide a piece of that information with the correct signature. I have really no clue how that works exactly, but there's a lot of crypto surrounded by it. And I know that our team is working with Microsoft Research to come up with a right solution in a standard way. And the other one is going back to the issuer and say, well, I need this credential, but with only this information, and pass it back. For example, if I want to prove I'm 20 years or older, well, this is my credential I got from you with my date of birth. Can you please give me a credential I can present with just like I'm older than 21? Then you get that credential. That's something you can provide to the relying party. The signature checks out, and they can allow you access. This is one of the things we still have to design, figure out with the community, and make sure we do it in a standard way. Another issue was it's nice that I own my own identity. So I'm DID 12345. I'm going to this relying party to sign in, Facebook, for example. Next time I'm gonna, I need an insurance, travel insurance, because I'm going on a holiday. I go to this insurance company, sign in with my ID, DID 12345. I'm not aware that this insurance company has a deal with Facebook that they can share personal information, and they find out that I post a lot of pictures of me skydiving, going mountain biking on dangerous roads and mountains, and they said, well, DID 12345, you're a bit too high of a risk for us, so we're going to decline your insurance policy. So I still want to use a single identity, but I want to be able to use that same identity without the possibility of those different websites correlate information. So they're coming up now with a standard way of doing that where I provide my identity, but it's not correlatable with somebody else, pairwise something. So a lot of these things are now being worked on through the DIF community, and make sure that it's a standardized approach, and everybody who's going to issue verifiable credentials and consuming verifiable credentials from anybody who's issuing those, either using Microsoft system or somebody else, can work together. So let me just pause if there are some questions here. What's the biggest advantage of diff versus centralized from business perspective? The real world problem. If you just want to authenticate people, think about if you're building a site, you want to allow anybody from outside your org to enter as well. So think about B2B, if that's familiar to you, without setting up the federation or inviting them as a guest inside of your tenant. We could use DID to do that and make it really easy. People bring their own identity. That's something you trust. And there might be a workflow how you're going to invite people and trust them, but that's what you can do. If you want to allow any student and you're a central system, are you going to have all those students create an account in your system, prove that they are a student before they can sign in and use your system? If you are building that system, okay, you got the expense tool, but you want to prove people have the right certification before they allow to use the expense tool. Can I build it today without a decentralized system? Sure. But it's going to be hard, especially when you want to do that for a couple of systems against a couple of training systems, for example. So I like to see where you disconnect the authorization system from the application you use and ask the user to provide the information to the proper authorization. So it saves you from implementing all those API calls on the backend, for example. So Paul asked if I have multiple DIDs. So the wallet is actually has to be smart enough to understand, wait a minute, it's asking for a university card, say for example, any university, and you happen to go to 2, you can choose which card you want to use. Could you use the concept of a scope to indicate what claims you want from the issuer? Yes, we don't support custom scopes yet, but that's something which you have to make part of the contract if you want to use an ID token to fill the claims. And yes, Nilesh, there's a repo. This is the website you want to read up on, and I can post it in the IAM window. So yeah, there's still a bunch of stuff we have to figure out and do. If you look at some of the code, and let me just show you the VS Code here. So we built an SDK, it's in Node, and I'm just an old dude doing a lot of .NET in the past, so Node is getting me a bit of a head scratch once in a while, especially when I suddenly have 30,000 files installed, but whatever. The first thing we do is ask to show a QR code. And what we do is we have a request store builder. We tell you, well, to the QR code, go here to retrieve the real request. That's what you typically see. QR codes are limited in the amount of information they can show. If you want to show a lot of information, you're going to have a lot of small pixels. It's going to be harder to scan. So what we actually do in the QR code is tell you, go here to retrieve the real request. And I showed you a bunch of slides with what the request looks like. Those requests can be really big because the contracts can be complex, etc. The next thing is that the phone, so well, I scan the code, I go back to we told them, go back to issue request. That's what I do here. And since I cached the request I built here in the cache, so this is the real request built, I cache it, I retrieve it. This is where the phone knows what to do. I have to sign in, I have to enter some information, etc., etc. Once it's done doing that, the response is sent back, and we will validate the response and make sure it's all trusted, etc., etc. So the website for issuing is actually very simple. Verifying is even simpler, and I know this is too much, but the GitHub repo is linked in the documentation I just sent. I just want to show at least a little bit of code, and maybe seem kind of smart. Here I have the configuration done. This is the verifying website. So I want to check, give me this QR code, and once it checks out, I'm going to get you access or a discount, whatnot. So I configure, in this case, a credential type. I want people to show me a credential which is from the schema educational credential awarded. And by the way, I like them from this issuer ID. And we use that information in the presentation request. So we're going to build the presentation request. Credential type, this is the one I'm requiring. I'm not even using the issuer here. And later when I'm validating, let me see, that's here. I'm going to create a validator. I'm going to check if that credential is actually coming from that issuer. That's what I do here. So the SDK makes all this work quite simple. So this is not a lot of lines of code. I don't know if it makes sense or not, but I specify in the request. I need. I'm just scrolling too fast. I apologize. Oh, here it is. I'm creating the request. I specify the credential type and require it. This is a really simple scenario. It could be multiple ones, right? I want this one, and this one. And then it's going to ask me for multiple ones. So how does that look like if I do that? I got a simple sample app I have here. Here it is. This is just a demo thing we have. So I require a business card, and I require a Woodgroove card, and I require, what was the other one? Oh yeah, the Contoso card. Create a QR code, if I now scan this, hopefully, and this I just do this on the fly. Look, it asks 3 of these cards, and I can now decide if I want to provide these. So what this request actually did was simply adding different schemas required, and I click accept. So it was approved. I can see the check response. This typically do automatically. So when I go now back to my card, I can actually see it was verified by the Decentralized Identity team. That's the site this is the site I just used. Same with the verified employee card. I can see the recent activity as well. So I can actually create requests which requires multiple cards to represent. And again, that's the thing we are trying to build now, is to implement a much richer presentation language where I can say, I just want this claim from this schema, I need this claim from that schema. Please provide me a combination, and then I'll let you in. Will DID offerings become available with Microsoft Live ID? Yeah, that's a good question. So what's going to happen? So my guess is this technology, since it's so new, it will be running side by side, and maybe in certain scenarios, it has to be the only technology. We are planning on building this as a first citizen inside of our offerings. So think about using a FIDO2 key. You can also use a VC to authenticate against, I don't know, Teams or something else. So this technology should be able to be used for that. So what are we building? We're building an issuing service. So how we get those public keys on the blockchain, that's actually really complex. With all the mining and the distributed system, people proving it, and the majority have to accept, blah, 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 and it's also slow. So we are working with the DIF ION project, and ION is actually a implementation of a side tree protocol on top of Bitcoin, where we can collect 10,000 transactions and put them on that distributed ledger. And think about Bitcoin or any blockchain as a append-only log file, which is cryptographically sound, can be tampered with, etc., etc. So that's the distributed network we're going to store. And there's a lot of fancy things going on. I don't even understand how it works, but I got an API. Issue me a credential from this type, and let the user go through the hoopla and issue that credential. That's what we're building. We're building a digital wallet. That's the Authenticator app. And we are building a bunch of SDKs. The ION network, which is on top of the ledger, that's something we are contributing code to the DAF ION project. So this is not that distributed network, that's not Microsoft technology, that's DAF technology, and we just happen to contribute code to their project, to make you understand. This is not a Microsoft solution. We're building a Verify SDK. That's the few lines of code I just briefly showed you, where we can verify the credentials and create those requests. We can use this to create an issue and request as well. There's a crypto SDK underneath. The Android SDK we have, that's the wallet piece of Authenticator. So Authenticator itself is not open source, but the wallet piece we are building, that SDK is open source. So you could pick it up and build your own wallet if you want to. So why are we using Bitcoin and Ethereum? Actually, there is an implementation of this on Ethereum. So the Side protocol is ledger independent. Ion is the Bitcoin implementation. There is one for Ethereum as well. Bitcoin is bigger. It's been around for a long time with an uptime of, I think, 5 nines for so far. So it's very secure and robust. That's one of the main reasons. But in theory, we could switch ledgers. We just happen to have now chosen Bitcoin. But they should be interoperable. So if somebody runs on Ethereum, since we have a universal resolver where they can figure out where's my DID 12345, they can go to the right network. Yes, there will be an iOS version. We just started on the iOS version for the wallet. So the goals of the Verification SDK. This is built by one of my colleagues here over in Belgium. Of course, we have to be able to verify credentials. And again, if you have ever seen any of my talks when we talk about building solutions on top of AD or B2C or whatnot, and handling ID tokens and access tokens, is like, please don't implement protocols yourself. It's easy to get started. It's hard to get right. It's easy to do it wrong and not insecure. Even validating a simple JOT is hard. I had no clue how complex it could be with all the different rules and exceptions you can have. And it's actually an angle of attack. So please use a library to verify credentials. You don't have to use ours if you don't want to. But the SDK helps you validate those tokens, create those COP requests, and self-issued OpenID Connect Protocol requests. So it's like OIDC, but self-issued tokens. That's the important piece of the protocol where we are using. If you want to use another step. So at this moment, it's Node. The blockchain community, the IAM community, and all that stuff is heavily node-based. So it's actually built in TypeScript, to be honest. So the links to the SDKs are in the end slide. This is the concept it used. It's the build a pattern, if you're familiar with it. I kind of like the SDK, how to use it. It's easy. I can just do a dot something and add it. For example, I didn't really show it, the crypto piece. I can use a private key from disk, but it's very easy to add a key vault and the private key as well. So it's very easy to extend. And here, when you build the validator, I only want to trust tokens from this issuer, for this audience, etc. And you can just add a bunch of them here. So it's a very straightforward pattern. I talked a bit about this stuff. So pairwise identifiers, that's the stuff which is not completely standardized, where I can use my same identity on different websites without them to be able to correlate. A big work item is still, how do I recover when I lose my phone or when I switch phones? We want to be able to restore a backup restore, but it has to be done in a standard way. If that's done properly, it's even possible to move from one wallet to another wallet. And again, everything we do is done through the community and the standards community. So we don't try to invent it ourselves. And if we invent something, it's always being validated with the community and make sure it's going to be in a standard. There's a white paper, there's some other information on OpenDID, but the project I just linked in the IAM window, that's the one I would get started. There's where we have the samples, the explanations, how it works. The one thing you cannot do today is issue credentials yourself through our system. We're still in private preview. What I'm trying to do myself is create a playground, which we're going to host. So customers can actually start using the playground to get credentials, and anybody can build a verifying website and ask for a certain amount of credentials. So I'm going to make sure that's going to be a playground where you can get several different credentials and start experimenting a little bit with the technology. There's a bunch of other developer community calls. This is from slides from Steven. So make sure if there's other topics you're interested in to join those. And I guess this is the last slide for today. So again, I quickly walk you through why we think DID is important. I personally believe that this is going to be the next big thing. There's so much stuff we can do with a decentralized identity. Think about devices talking to other devices. There's actually a standard way to do that with distributed identities as well. So you don't need a central system where everything is registered for everybody. You can actually start decentralizing those systems and trusting those. So at the moment, there's no plan for .NET yet. So at the moment, it's all Node. Nothing prevents you from creating a little Node service that you can call from your .NET packages, and that's the approach I would recommend today. Makes it really easy. So you host the Node stuff somewhere else, and you just call the APIs you provide yourself. And why is the demo not done in TypeScript? I'm not sure why. I know Danny built it. I guess he liked JavaScript better. I don't really mind. It's more the same. Let's be honest. The sample is really simple. So it's very easy. If you want to use TypeScript, it's very easy to pick it up, right? When is this ready for public preview? I think what we announced at Build was somewhere in the end of this calendar year. I think that was the date. And if I'm lying now, then okay, I guess I said something I shouldn't have said, but I think that's what we said publicly. What I like about this project that is actually done in the open. Every code, all the code we are building, except for the backend issuing service, but all the SDKs and all that stuff, it's on GitHub. So on the DID project, you find the link to the GitHub repo as well. That seems to be all the questions so far. Anything else? Did it make any sense, or like, yeah, Matthijs, you don't make sense at all. You have to start over again. So today, as a developer, it's probably, oh, thanks, Jen. I'll make sure they fix the link. Short term, there's nothing to do for you as a developer, right? The technology is not available, although there are some competitors who build similar technology. They might have their own implementation, not standard-based or not, but there's other players in the market. But I think as a developer or an architect, it's smart to start thinking about what this kind of technology can do and how you would solve your problems in the future. So maybe not in a bigger ecosystem play yet, but for your solution, I think it makes sense. We see the customers we're working now actually have really good use cases where this technology actually solves a lot of problems. We see a lot of interest in the market for people where they, like the initial scenarios are sketched. I didn't make them up. That's actually real questions we have for customers, how they would solve that technology. So this is not something we just dreamed up and hopefully it will land somewhere. This is actually coming from real customer demand. It's just a really different way of approaching the problems. And that's, to be honest, my mental model is still changing, right? For example, you have an account which is valid or you don't. But a driver's license can be invalid and it can still prove I'm 20 years old, at least 20 years old. So there's going to be different concepts you can use and different problems you can solve with this technology. That's what I like about it. So, all right, it's a minute for the hour. Thank you for joining today. Feel free to reach out if you have any more questions. It's my first name, last name @microsoft.com, or reach out on Twitter. And yeah, I'll talk to you guys later.
Thank you so much, Matthijs, and thank you everyone for joining us today. Have a great day.